This is standard 8, EEC8. We're going to use simultaneous equations to understand that solutions to a system of two variable linear equations is their point of intersection, because the points of intersection solve both equations simultaneously. What does all that mean? That simply means that if you have two lines that are intersecting, the one point where they intersect is the only place that's a solution for both of those equations simultaneously. Right here, this point is a solution for both y is equal to 2x plus 4 and y is equal to negative 2x plus 8, because it is on both lines. If someone asks you for the solution for this system of equations, all you have to do is read it off the graph. The solution, the estimated solution, is 1,6. It's the only point that's on both the lines. Now, I'm going to prove to you that this is indeed a solution for both of them. If it's a solution, it's not only on the line, but it will make the equation true. Let's start with this one. Y is equal to negative 2x plus 8. 1,6. If I have 1,6, this is my x, that's my y. I'm going to substitute them in. Is 6 equal to negative 2 times 1 plus 8? Is 6 equal to negative 2 plus 8? Yes, 6 is equal to 6. So, yes, this is a solution. Let's try the other equation. Y is equal to 2x plus 4. My y is 6. My x is 1. Is 6 equal to 2 plus 4? 6 is indeed equal to 6. So, yes, this is a solution for both of these equations. Now, I want to show you something. What if we chose a point and asked if it was a solution for the two equations? What about this point? Would it be a solution for both those equations? Well, it shouldn't be. It should be a solution for this one because it's on this one, but it shouldn't be a solution for this equation. Let's look at this point. It's at 2, 4. We're going to try 2, 4, and I'm going to show you that it is a solution for this equation, but it's not a solution for this one. Let's start with y is equal to negative 2x plus 8. Y is equal to negative 2x plus 8. And now we're trying this point 2, 4. We're going to see, is it a solution? Let's plug it in. Here's your x, here's your y. 4 is equal to negative 2 times 2 plus 8. 4 is equal to negative 4 plus 8. 4 is equal to 8 plus negative 4 gives me 4, isn't it? So yes, this is a solution. And that makes sense because it's on this line. If it's on the line, it is a solution. Let's see if this blue point is a solution to that one. Y is equal to 2x plus 4. Our y is 4. Our x is 2. We're going to plug it in. Y is equal to 2 times 2 plus 4. Is 4 equal to 4 plus 4? Is 4 equal to 8? No, it's not. So this is not a solution. Well, that for this line, that makes sense. This point is not on this line. This point where the two of these intersect, where the two lines intersect, is the only solution for both these lines simultaneously. And if you have that situation, your y's are equal at that point, your x's are equal at that point. Now, let's try another one of these. In this case, we're going to solve a system of two variable linear equations algebraically. And then we're going to estimate the solution by graphing it. Well, I've already graphed them for you. What we're first going to do is we're going to solve this algebraically. I know that if I've got this point right here where these two lines intersect, see, I've already plotted them out for you. Here's your y is equal to 2x minus 3. This is this equation. I solved it for y and I plotted it out. I know that at this x, y value right here, these y's are equal, these x's are equal, only at this point. If that's the case, and this is y, I can substitute this in place of this y. When I do that, it will allow me to find my x value and my y value. X minus 3, and in place of this y, I'm going to put a parentheses and dump in what y is equal to, because see, y is equal to this, the 2x minus 3, okay? I'm going to close parentheses and say equals 4. X, okay, now we're going to use distributive property. Negative 3 times 2, negative 6x. Negative 3 times negative 3 is positive 9. That gives me my 4. Let's combine like terms. X minus 6x is negative 5x plus 9 equals 4. Let's subtract 9 from both sides. I've got negative 5x is equal to negative 5. Divide both sides by negative 5, and I've got x is equal to 1. Okay, so now I've got what the x should be. It should be 1, right? Is my x 1 on this point? It is, it is. Okay, now let's find my y. To find y, I'm just going to plug my x in. Take either one of these equations, either one, plug in the x and find the y. Y is equal to 2x minus 3. My x was 1. Let's substitute it in. Y is equal to 2 times 1 minus 3. Y is equal to 2 minus 3. Y is equal to negative 1. So my x is 1, my y is negative 1. My solution for these two simultaneous equations, for these two system of equations, is 1, negative 1. Let's look and see. Is that where we are on our chart? Is that where we are? 1, negative 1. Yes, indeed, it is. So if we graphed it, we can see that we would get the same value as if we work it mathematically. So why don't you always graph it? Well, sometimes you have a fraction for these answers. So graphing is just an estimate. We have to work it out mathematically. But graphing can help you check your answer. Let's try another type question just like this. We're doing the same thing here. But now we've got one where neither one of them says y is equal to. I can't just plug it in. I'm going to show you something. The other one was called substitution. I'm going to show you something that we called elimination. When you use elimination, you get rid of one of the variables. Okay, so we need to eliminate one of these variables to be able to solve these. I've already plotted them for you. We can see where they intersect. We're looking for this xy value. That would be where the two lines intersect, the one point that they both have the same value. Since the x's and y's are equal at that point, and we're looking for that point, we need to get rid of one of these. Well, if you look at this, there's no real way to get rid of it. If I'm adding these two equations together in elimination, what I can do is I can say if I've got a positive 2x here and I add a negative 2x to it, I could get rid of that x. But how can I add a negative 2x to it? What if I multiply everything here by negative 2? Now, that's going to give me this. I'm going to keep what I've got here. 2x plus y equals 6. Let's use distributive property here, and I'm adding these. Minus negative 2x, a negative 2 times a negative 4y would give me positive 8y. A negative 2 times 12, positive 12 would give me a negative 24. Okay? 2x plus negative 2x gives me 0. This is gone. 1y, because if there's nothing there, we know it's 1. 1y plus 8y gives me 9y. 9y. And 6 plus negative 24 would give me negative 18. Let's solve for y. Let's divide both sides by 9. And I have y is equal to negative 2. Okay, I've got my y. It's negative 2. Let's see, does that make sense? Oh, that makes sense. We need to find our x now, don't we? To find our x, I'll plug my y into either equation. To find x. Okay, let's try either equation. How about 2x plus y equals 6? Well, my y is negative 2, so that's 2x plus negative 2 equals 6. Move this down a little bit so we can see it. 2x minus 2 equals 6. I'm going to cross the equal sign. I'm going to add 2 to both sides. 2x is equal to 8. Divide both sides by 2. X is equal to 4. That tells me my x is 4, my y is negative 2. It tells me these two equations should intersect at 4, negative 2. 1, 2, 3, 4, negative 2. So my point of intersection is 4, negative 2. My solution for that system of linear equations is 4, negative 2. Now let's try this as word problems. We're going to solve real world and mathematical problems that involve two variable linear equations. On this first one, the Woodson and Baker families went to Burger Shack for dinner. The Woodsons bought 3 burger meals, 4 hot dog meals for $48. Can I write an equation from that? What if I say B is the what? What are we looking for here? The cost of each meal. B is the cost of a burger meal. And how about we use H for hot dog meal? H is the cost of a hot dog meal. Okay. And let's put these two together. We've got 3 times the cost of a burger meal plus 4 times the cost of a hot dog meal was $48, right? Okay, we've got an equation for that. We're going to do 2 equations. When you have 2 unknowns, what you have to do is you have to do 2 equations with 2 unknowns so you can eliminate one of the variables. The Bakers bought 6 burger meals and 2 hot dog meals for $60. So we got 6 burger meals plus 2 hot dog meals, and that cost us $60. Okay. I need to get rid of one of these. I need to eliminate one of the variables. What are they asking me for? How much does each meal cost? So I want to know what the hot dog meals cost. I want to know what the burger meals cost. I'm in a tough situation here. I don't have any easy way to get rid of it. But I could get rid of the burger meals if this were a -6, couldn't I? If I multiplied everything here by -3, or by -2, couldn't I get rid of that? Let's try that. Let's multiply everything here by -2. -2 times 3 would give me -6b. -2 times 4h is -8h. -2 times 48 would give me -96. And then we add these together. We have 6b, we're just bringing down what's here, plus 2h equals 60. Okay, let's add these together. -6b plus 6b, that's gone, that's 0. -8h plus 2h would give me -6h. -96 plus 60 would give me -36. Divide both sides by -6, and h would be 6. So our hot dog meals are $6 a piece, right? How do we find the cost of our burger meals? All I've got to do is plug this back into one of these, right? 3b plus 4 times h equals 48. My h was 6, so 3b plus 4 times 6 equals 48. 3b plus 24 equals 48. Subtract 24 from each side. 3b equals 24. Divide both sides by 3. b is equal to 24 divided by 3. 8 times 3 is 24. That's 8. Okay, your hamburger meals are $6 each. Your burger meals are $8 each. And then we've got one more down here we're going to try. She had bought mushrooms and tomatoes at the grocery store. Okay, tomatoes cost $2 per pound. Mushrooms cost $3 per pound. She spent a total of $17. The total weight of her mushrooms is 5 times greater than the weight of her tomatoes. How many pounds of each did she buy? Well, I've got two equations. I need I've got two variables. I need two equations. So let's see if we can write two equations from this. First off, we said her mushrooms cost $2 per pound. Her tomatoes cost $2 a pound, mushrooms $3, and she spent $17. So what if I say this? T is going to be the pounds of tomatoes. See, I'm identifying my variables first. I use something that makes sense. There's tomatoes, there's mushrooms. M's equal to the pounds of mushrooms. Okay. We said the tomatoes are $2 per pound. So $2 times the number of pound of tomatoes plus $3 times the number of pounds of mushroom gives me the total I spent, which was $17, right? Let's look at the other equation that we can write. She spent a total of $17, and the total weight of her mushrooms was 5 times greater than the weight of her tomatoes. Okay? So if I take the mushrooms, the total weight of her mushrooms is 5 times greater. So 5 times greater. Her tomatoes, if I take her tomatoes and I multiply that times 5 times the weight of the tomatoes, 5 would be the weight of the mushrooms, right? So now we're going to need to substitute this 5t in for our m right here. Oops, hold on, let's put our pen back. 2t plus 3 times 5t equals 17. 2t plus 15t equals 17. 17t equals 17. Divide both sides by 17. The weight of our tomatoes would be 1 pound. T is 1 pound of tomatoes. Okay, so if I've got 1 pound of tomatoes, I can plug this back in. The mushrooms would be 5 times the weight of the tomatoes. So the weight of the mushrooms would be 5. Okay, our answer would be tomatoes equal 1 pound, mushrooms equals 5 pounds. And this shows that we can use a system of two equations with two unknowns to be able to solve any sort of word problem that's got two different variables in it.